Today I am going to talk about Newton's backward difference method. So here the temperature versus viscosity is given. So these are the glycerol viscosity data. So from this data I have to calculate the glycerol viscosity at temperature 32.5 degrees centigrade. So first we must know what is the Newton's backward difference formula. So Fx is equal to f of xn plus p nabla of fxn plus p into p plus 2 by factorial 2 nabla square f of xn, p into p plus 1 into p plus 2 by factorial 3 nabla cube f of xn plus dot dot dot. So where p is x minus xn by h is the step size, nabla is backward difference operator, and xn final point in the data set. So now these are my data, glycerol viscosity data, temperature versus viscosity. Using that, now here the temperature data is given, that is nothing but x. This is f of x, that is nabla of f of x, nabla square f of x, and nabla cube f of x. So now from this data, first we have to calculate. So as this is backward, so we have to go backward direction. So from here to here, so here to here, so we'll get this data. So 284 minus 392 will get minus 108. From here to here, so we'll get this data. So 392 minus 612, so that is minus 220. So from here to here, this, so that will be the data, 612 minus 954 minus 342. So now from here to here, this data will get 954 minus 1490 is minus 536. So now from this data we will calculate again from the backward direction. So from this data and this data we will get this data. So minus 108 minus of minus 220, so that is 112. So this data and this data, so I'll get this. So minus 220 minus 342, that is 122. So now from this data and this data we'll get this data. So minus 342 minus of 536, that is 194. Again backward, from this data and this data we'll get this data, 112 minus 122 is equal to minus 10, and from this data and this data we'll get this data, so minus 72. Now here interpolation point t is equal to 32.5 degrees centigrade, and here final point, so xn, so that is 35 degrees centigrade. So we have to take this data, this data, this data, this data, and this data to calculate the viscosity. Now values needed, so f of x, that is 392, del f minus 220, then del square f 122, and del cube f, that is minus 72. So now we have to plug all this data to that formula. Okay, so before that, the setup. So t is, we know, xn is 35 degrees centigrade, h is 5 degrees centigrade. Now we have to calculate p. P is 32.5 minus last point, that is 35 by 5, so that is minus 0.5. And this data we already got in the previous slide. Now we plug all this value in this Newton backward formula. F of x is equal to f of xn plus p nabla f of xn plus p into p plus 1 by factorial 2 nabla square f of xn plus p into p plus 1 into p plus 2 factorial 3 nabla cube f of xn plus so on. And then here, so you can see that f of xn already 392, and then p is minus 0.5, nabla f of xn, so that is minus 220. Similarly p is minus 0.5, p plus 1, that is minus 0.5 plus 1 factorial 2, nabla square f of xn is 122, then plus p is again minus 0.5, p plus 1, that is minus 0.5 plus 1, p plus 2 minus 0.5 plus 2, then factorial 3 is in the denominator, and then nabla q f of xn is minus 72. So now if you put all together and if you calculate, the first term is 392, second term will be 110, third term will be 15.25, and fourth term will be minus 3. So now if I add all together, So here if I all together I will get that mu at 32.5, so that is 514.25 cp. Now if you check, so that value will be between 612 and 392, and this also follows the expected viscosity term trend, and then magnitude of the succeed term decreases. So if you see here, so this term actually decreases. So initially 392, then 110, then 15.25, means each term actually decreases. So that is also so that that result is correct, and physical significance maintained. Okay, the trend is maintained means physical significance also maintained. So that's it about Newton backward difference. That's it. Thank you.